Hello learners. The topic for today is secondary storage structure. Let's start with knowing what is disk structure. Disk drives are addressed as large one-dimensional arrays of logical blocks, where the logical block is the smallest unit of transfer. The one-dimensional array of logical blocks is mapped into the sectors of the disk sequentially. Sector 0 is the first sector of the first track on the outermost cylinder. Mapping proceeds in order through that track, then the rest of the tracks that cylinder, and then through the rest of the cylinders from outermost to innermost. Now, moving ahead to the understanding of disk scheduling. The operating system is responsible for using hardware efficiently. For the disk drives, this means having a fast access time and disk bandwidth. Access time has two major components: seek time. Seek time is the time for the disk to move the heads to the cylinder containing the desired sector. Second, rotational latency. Rotational latency is the additional time waiting for the disk to rotate the desired sector to the disk head. Minimize seek time. Seek time is equivalent to seek distance. Disk bandwidth is the total number of bytes transferred divided by the total time between the first request for service and the completion of the last transfer. Several algorithms exist to schedule the servicing of disk input-output requests. Going forward, let us see what disk management is. Low-level formatting or physical formatting. Dividing a disk into sectors that the disk controller can read and write. To use a disk to hold files, the operating system still needs to record its own data structures on the disk. Partition the disk into one or more groups of cylinders. Logical formatting or making a file system. Boot block initializes system. The bootstrap is stored in ROM. Bootstrap loader program. Methods such as sector sparing used to handle bad blocks. Here is a diagram showing the process of booting from a disk in Windows 2000. Last but not the least is swap space management. Swap space. Virtual memory uses disk space as an extension of main memory. Swap space can be carved out of the normal file system, or more commonly, it can be in a separate disk partition. Swap space management. 4.3 BSD allocates swap space when process starts, holds text segment and the data segment. Kernel uses swap maps to track swap space use. Solaris 2 allocates swap space only when a page is forced out of physical memory, not when the virtual memory page is first created. This is all for the presentation. Hope it helped you in understanding the concepts better. Thank you.